All right, so today we're starting differential equation and mathematical modeling. Differential equation is chapter 17. All right, so here's how we start out. We'll start out by saying that any relation between the variables x, y, and any or all of the derivatives dy by dx, d2y by dx squared, d3y by dx cubed is called an ordinary differential equation. The order of a differential equation is the highest derivative in the differential equation, and the degree of the differential equation is the power to which the derivative of the highest order is raised. For example, dy by dx plus y is equal to x. X is a first order linear differential equation. First order, since the highest derivative is the first derivative, so that makes it the first order, and linear of degree 1, since it is raised to the power of 1. So dy by dx is raised to the power of 1, so that makes it linear. d2y by dx squared plus dy by dx plus y is equal to x is a second order differential equation. Second order, since the highest derivative is the second derivative, and linear, since the highest power of the highest derivative is 1. Now, this chapter deals with solving first order linear differential equation and second order differential equations. So we're only looking at first order linear differential equation and second order, it's actually second order still linear differential equation. So again, whenever you see order refers to the highest derivative. So dy by dx would be first order, d2y by dx squared would be the second order if they're the highest derivative. Now the degree refers to the power of the derivative, or power of derivative of highest order. So if the power is 1, it's the first degree, and we say that is linear. All right, if the power is 2, then that will be second degree. Linear means that the highest power of the highest derivative is 1. All right, I'm going to All right, so next we're going to look at the first order linear differential equation. This says the equation dy by dx plus py is equal to q, where p and q are functions of x alone or constants. So p and q could be functions of x alone, or they could be constants. They could be constants involving y and dy by dx is the first degree to the first degree only is known as a first order linear differential equation. So let me read that again. So the equation dy by dx plus py is equal to q, where p and q are functions of x alone or constants involving y and dy by dx to the first degree only is known as a first order linear differential equation. All right, let me go through the theory that allows them to come up with the solution for a differential equation of this form. All right, I have a look at heading that says observation. What they observed is that So somebody had to come up with this solution, and this is what, in trying to work out this solution, whosoever came up with the solution made this observation, that if you differentiate y e to the integral of p dx, what you get is, so let's differentiate. We're differentiating this. All right, now when you differentiate, it's a product. So you would what? Leave the first, differentiate the second. The second is e, the integral of p dx. When you differentiate e to the x, you're going to get back e to the x. But you have to multiply by the differential of the inside function. The inside function will be the integral of p. And since differentiation is the opposite of integration, when you differentiate the integral of p, you're going to get back p. So it's leave the first, differentiate the second, plus differentiate the first. When you differentiate the first, which is y, you get dy by dx. Leave the second, e to the integral of p dx. E to the integral of p dx is common, so you can factor that out. And you'll end up with e to the integral of p dx, and in bracket dy by dx plus py. All right, now, so it means therefore, since when I differentiate y e to the integral of p dx, I'm going to end up with e to the p dx, and in bracket dy by dx plus py. It means that if I integrate that, I'm going to get back y e to the integral of p dx. So that's an observation. Now, the differential equation, remember, is dy by dx plus py is equal to q. That is what you want to solve. Now, in solving this, since I know that if I integrate e to the p dx, dy by dx plus py in bracket, I'm going to get y e to the integral of p dx. What the person did in order to come up with a solution, which is here, the person multiplied both sides of the equation by e to the integral of p dx and then found the integration. When you integrate, remember, e to the integral of p dx in bracket dy by dx plus py, you're going to get y e to the px, and this is equal to the integral of q e to the px, e to the integral of px, and then you're integrating with respect to x. Again, integrating with respect to x. All right, and if you divide both sides by e to the integral of p dx, you would come up with the solution of your differential equation. All right, so that is the theory behind the solution. Let us see if we can give you an example of this thing in action. All right, so example 1 is asking us to solve the differential equation dy by dx plus y is equal to x. So first of all, this is of the form dy by dx plus py is equal to q, where q and p are functions of x alone, or they are constant. So in this case, p would be equal to 1 and q would be equal to x. As part of the solution, I'm going to need the integral of p dx. So the integral of p dx would be the integral of 1 dx. And when you integrate 1 with respect to x, you're going to get x. So the solution is going to be y. So now the solution would be y e to the integral of p dx is equal to the integral of q e to the integral of p dx. All right. So it would be y e to the integral of p dx, but the integral of p dx is equal to x. And this is equal to the integral of q. Remember, q is x, e to the integral of p dx, which is x. So this is x dx. So in order to get my solution, I need to integrate x e to the x. Then I'm going to integrate that partially. So if I integrate that, u has to be something. Integration by parts, u is equal to x, and dv by dx is equal to e to the x. du by dx is equal to 1, and v is equal to e to the x. So continuing my solution, y e to the x would be equal to u v. So u v would be x e to the x minus the integral of v e to the x times du by dx, which is what? 1 dx. So this is x e to the x minus e to the x plus c, which is the constant of integration. So if I divide the entire equation by e to the x, I'm going to get y is equal to x e to the x minus e to the x plus c divide by e to the x. Y is equal to x minus 1 plus c e to the minus x is my general solution.